Hello ladies and gentlemen, today we're going to look at solving inequalities. This is Algebra 1 review, probably even earlier than that. So let's see, what do you remember? Your learning targets for today, you need to be able to solve a simple inequality, solve a compound inequality, and also sketch solutions to an inequality on a number line. So, what's the difference? Equations, inequalities. Well, equations, they have an equal sign. That's why they're called equations. Inequalities that have what's known as inequality signs. So less than, greater than or equal to, less than or equal to, etc. Right? Steps in solving them. You're going to do exactly the same thing. You're going to do inverse operations to isolate the variable. You got to get him alone. He does not do well with others. But inequalities have some really kind of things you got to remember about. I would definitely write this down right here, okay? You don't need to write anything else down, but you do need to write this down. When solving, if you happen to divide or multiply by a negative number, you gotta flip the inequality sign. A few of you forgot to do that on your pretest. Then you need to make sure you sketch your solutions on a number line. So, let's actually take a look. What does that look like? Here's an example. 6x is greater than 32 minus 2x. So very first thing, act like that's an equal sign. Solve it like normal. So I'm going to add 2x to both sides, get my x's on one side, numbers on the other. So I have 8x is greater than 32. I need to solve for x, so I'm going to divide by 8. Now I divided. Let's do a double check. Did I divide by a negative? I didn't. Okay, something to keep in the back of my mind. So I got x is greater than 4. That is the answer to this inequality. So what this means, I could plug in 5, 6, 4.01, and it would work in this particular inequality. It would not work if I plugged in 4, because that's not equal to. Now, what does it mean to sketch? How are you going to sketch this is you're going to put 3 lines on this number line. 4 is going to be in the middle. And then put one number that's less than him and one number that's greater than him. So I got 3 here and I got 5 here. So I then need to figure out, do you guys remember the closed dot or the open dot? So open dot meant that it was not equal to, because it's not equal to. Notice how it's not equal. So I'm going to have an open dot at 4, and then I need to figure out which side to shade on. So I'm told x is greater than 4. So is 3 greater than 4 or is 5 greater than 4? Well, of course, 5. So I'm going to shade on that side of my dot. Let's take a look at this one. So I have 10 is less than or equal to 6 minus 4x. Very first thing I'm going to do, I'm going to get my numbers all to their own side. So I'm going to subtract 6 from both sides. I'm going to get 4 is less than or equal to negative 4x. Looks like I need to solve for x. Gotta divide by negative 4. Now, there should be a little warning light in the back of your head going, warning, warning, warning. You divided by a negative. That's good. You gotta keep that in the back of your mind. Since I divided by a negative, not only do I get negative 1, but notice how I have less than? I'm going to flip my sign around because I need to. I need to flip that sign. I divided by a negative. So, what are we going to do now? Well, I solved it. I have negative 1 is greater than or equal to x. That's kind of hard to read. So what I'm going to do is I'm going to flip it around. Notice the x still has the little point, the point being pointed to it. I just made it so I can see the x on the left. I like seeing the x on the left for inequalities. It's a lot easier to graph with, by the way. So, negative 1 is going to be in the middle. 0 is going to be on that side. Remember, bigger numbers to the right. And then negative 2 would be on that side. Since I have less than or equal to, you get a closed dot right there. Now, where are the x's less than or equal to negative 1? Well, smaller than negative 1 would be going toward negative 2. Now, if you would have read it this way, you would have had to think negative 1 is greater than or equal to x. I think it kind of confuses a few students. I like when x is on the left. I think it's a lot easier. Number 2, you're here's another good little trick. Notice how I shaded this way and the arrow was pointing that way? If the x or the variable is on the left, you can always follow the inequality sign's arrow. Compound inequalities. These basically are two inequalities slammed together to make one big inequality. We call these two things. This is called an AND inequality. Notice how there's both of them together. And this is called an OR inequality. Alright? Now, there's not much different, just a little different. First, let's take a look at our AND inequality. So basically, notice how I have a negative 12 is less than 3x minus 1, which is less than or equal to 3. Basically, what you're going to do is you're going to solve the equation, but you need to keep track of all the sides. So normally, if I would have not had this negative 12 here, if this would have been covered up, I would have done 3x minus 1 is less than or equal to 3. I would have added 1, right? Well, instead of just adding 1 there, you're going to add 1 on this side as well. Got to keep it all balanced. It's that balance beam act, okay? So negative 12, I'm going to get negative 11 here. Still 3x in the middle. And then 3. I need to get x alone, so I'm going to divide by 3. Now, not only am I dividing by 3 here, I got to divide by 3 over here too. So I got to divide everywhere. Hold on. 3 plus 1 is not 3. A few of you probably thought I was off my rocker there. There we go. That should be 4. I can count now. Alright, so then I get negative 11 over 3 is less than x, which is less than or equal to, my pen decided to go a little wonky there, 4/3. Got all my answers. Now, compounds, what you need to do, I just write the two numbers that I got for an answer. You can put 0 in the middle if you want that number in the middle. By all means, do so. Now, I need to figure this out. I know for the negative 11/3, I'm going to have an open dot. And on this side, I'm going to have a closed dot. So I'm first going to fill in my dots. Now I got to figure out which way am I shading. So I'm going to read from the variable on this side. X is greater than negative 11/3. Well, if he's greater than, he has to go this way, right? X is less than or equal to 4/3. Well, if he's less than, he's got to go this way. Notice how they're bouncing in between each other there. And inequalities, 95% of the time, will make a graph that bounces between the two graphs, which is pretty cool. I like how they kind of bounce in between, because it's an and. It's staying in the middle. They don't break apart. Now, for the ones that break apart, those are your OR inequalities. So let's take a look. Notice, I have two completely different problems that I'm going to work on. Treat them as two different problems. So I'm going to solve this left-hand side one first. So I'm going to subtract 5, get 9 on that side, divide by negative 9, and I'm going to get x is greater than, notice, divided by that negative. Warning light should have been going off in the back of your head. 9 divided by negative 9 is negative 1. So I've solved one of my problems. Let's try this one. Add 17 to both sides. I get 20. Negative 4x just comes along for the ride. Divide by negative 4. Uh-oh. Gotta flip my sign here. So I should get negative 5. Perfect. So my answer is x is greater than negative 1, or x can be less than negative 5. So let's write our two numbers. I have negative 5 here, and then negative 1 is bigger than negative 5, so he's going to go over there. So x is greater than negative 1. I'm going to have an open dot there. And x is less than negative 5, so there's an open dot there. Now, notice how he's greater than negative 1. So I'm going to go to the side that's greater. X is less than negative 5, so I'm going to go less than negative 5. Notice, ORs go outwards. O and O. Outwards and OR. They both start with O. That's going to be a good way for you to remember that they're going to go out from each other. And goes in, or is out. Okay? Then that is like 95%. There's those random ones that will do it. However, they'll do it the other way, but majority of the time you will see this happen with an OR inequality. And that's the end of this video. See you later, Sabers.